Hello and welcome to Mr. Tompkins EdTech. This series of videos provides work solutions for the GCSE Maths topic test produced by AQA. This video is Sine and Cosine Rules. Whilst these topic tests make excellent exam preparation and revision material, regardless of which exam board you're sitting, they are particularly useful for students studying for AQA as they are prepared by the same team who will be writing your papers in the summer. They will work best if you try and answer the questions yourself before watching the video. The topic test papers can be downloaded from this address, which I've also linked in the description below. They'll require a teacher account to access, so either ask your maths teacher to download and share them with you, or alternatively you can try pausing the video and attempting the question first before pressing play again to listen to my solutions. Check this playlist for all the other topics I've covered. I'm busy recording all of these topic tests, so if the particular topic you're looking for isn't there yet, why not drop me a comment below with your request and subscribe to my channel to receive notification of future uploads. If there is anything you don't understand, please ask in the comments. Make sure you mention the question number and try to be as specific as possible. I try to answer all questions promptly, especially around exam times. If you found the video useful, please do hit the like button, as this really helps me out. You might also like to check out my exam paper walkthroughs covering all the recent papers and practice papers from AQA. Just click on the card appearing at the top of the screen now. Okay, let's get started. So this is the Sine and Cosine Rules topic test from AQA. Now it says use the diagram to answer questions 1 to 3. So we're going to be using this non-right-angled triangle diagram. Before we get going though, let's just have a quick look at the diagram. Now you'll notice with these trig questions, the corners or the vertices are all labelled with capital letters. So I've got A, B and C. And you'll notice that the sides are all denoted by lowercase letters. I've also got A, B and C. And if you look carefully, you'll see that these sides and angles are paired up. So angle capital A lies opposite side A, and angle B lies opposite side B, and angle C lies opposite side C. And that is the way we need to label up triangles when we are dealing with trigonometry in non-right-angled triangles. Okay, it's important to do it that way because that's how the sine rule and the cosine rule are given in terms of those three sides and angles. Okay, question 1. Which of these formulas is correct? Circle your answer. Okay, so we've got 4 possible variants of the sine rule. Now the sine rule you can either give as A over sine A equals B over sine B equals C over sine C, or the other way around with the sines at the top and the angles at the bottom. That doesn't matter. Now we never use all 3 parts of it, we only ever use kind of 2 bits of it. Can I rearrange 2 parts of it into one of these 4 expressions? Now as mentioned, we only ever use 2 of the 3 parts of the sine rule, so anything that mentions A, B and C is not a correct statement about the sine rule. So that one there and that one there can't possibly be correct. So it's either A over sine A equals sine B over B, or it's A over B equals sine A over sine B. Now let's have a look at this first part of the sine rule. Now I could cross multiply that B and that sine A, switch them round. That would give me A over B is equal to sine A over sine B, which is this option here, isn't it? Okay. I couldn't make it that first one because they're the wrong way around, so it's not going to be that one. So it's A over B is equal to sine A over sine B. Question 2. Which one of these formulas is correct? So these are wannabe cosine rules. Now the cosine rule always starts out like Pythagoras theorem, which you've got at the beginning here, a squared equals b squared plus c squared. And then after that you get minus, then generally you get whatever 2 values you get here, you get repeated here, and whatever is at the front is at the back. That's how I kind of remember it. And there is a minus sign in the middle. Okay, so the correct one is that one there. A squared equals b squared plus c squared minus 2bc cos a. So like I say, that's how I remember it. That one and that one reappear here, and the first one is the same as the last one. Okay, so I am going for that one there. Question 3 asks which one of these gives the area of a triangle. So the area of a triangle formula that involves trigonometry has an angle. So if that was angle A, that would be side A. And I suppose if that's B and C, that would be side B and C. Now the equation for a triangle is always two sides and an included angle. So you're looking for two sides and the angle between them. So it's going to be the one involving BC and angle A. So it's this one here, half BC sine A. Question 4. The area of this triangle is 28 centimeters squared. Work out the size of angle A. Okay, so we looked at this formula last question, didn't we? So the area of a triangle is going to be given by half BC sine A, where B and C are your two sides and A is the included angle in between. Okay, but here we don't know what A is, but we know the area. So we can rearrange this to make sine, well, A the subject of the formula, and then use inverse sine to find the angle. So let's try rearranging it first. And so that moving this 2 up here and the BC down, we're going to get sine A is equal to the area, or 2 lots of the area, divided by BC, which is equal to 2 lots of 28 divided by 8 times 14. Okay, so reaching for a calculator. Well, do I need to reach for a calculator? Let's see if I can work this out actually. That 14 cancels into the 28. 14 goes into 28 twice. 2 times 2 is 4, and 4 divided by 8 is a half. So the sine of my angle is equal to half. So I don't need a calculator. I just know what the angle is already. So if sine of my angle is a half, then A must be 30 degrees. How did I know that? It's because I know my exact angles for sine, cosine, tangent for 30, 45, and 60, and you should know those too. Question 5. Work out the size of angle C. Now, we know this test is on sine rule and cosine rule, but this is how a question would be worded in the main exam as well, and you'll have to work out from here that it is a sine rule or a cosine rule question. So what are the clues? Well, you've got a non-right-angled triangle of which you know some sides and angles, and you need to work out some other sides and angles. That should tell you that it's trigonometry, and the fact that it's a non-right-angled triangle should alert you to it being either the sine rule or the cosine rule. So, if I know it's the sine rule or the cosine rule, how am I going to decide which one to apply? Have a quick look at this picture here. The sine rule is about opposites. It's about opposite sides and angles. For the sine rule to work, you need 2 pairs of opposite sides and angles. So one side matching with its angle and another side matching with the angle that you want to find, or the other way around. The cosine rule is about either that you have 3 sides given and you want an angle, or you've been given 2 sides and the included angle and you want to find the 3rd side. That would mean that you would use the cosine rule. Here we've been given this angle here, angle A, and we've been given side A, which is opposite it. So I've been given 1 pair of matching sides and angles, and I've been given this side here, and I want to find this angle over here. So that tells me I'm going to be using the sine rule. So remember, sine rule is about opposites. You're looking for 2 opposite pairs of sides and angles, and that's what we've got here. So let's just write out the sine rule in terms of this question. Now the thing we want to find is the angle, so we're going to write the angles on the top. Now the big full sine rule has got three parts, isn't it? Sine A over A equals sine B over B, which is equal to sine C over C, but we only ever use two parts of it. Now this time we have angle A and side A, so we're going to be using this part, and we have side C and we want angle C, so we've got that part there. So I'm going to be using sine A over A is equal to sine C over C. Okay, so let's just sub all the bits in that we know. So sine A, the sine of 48, so sine 48 over A is that side there, it's 9. Sine C is what we're trying to find, and we're going to be dividing it by side C, which is this one here, isn't it? The one opposite angle C, which is 5. Okay, so I've got sine 48 over 9 is equal to sine C over 5. Rearranging that, kind of running out of space here. Let me write over here. So rearranging, sine C is equal to, well, what I'm going to do is take that 5 and cross multiply it up here. And that's going to give me sine C is equal to 5 lots of sine 48, all divided by 9. Okay, so time to reach for the calculator and tap that in. 5 sine 48 divided by 9 is equal to, now my calculator is giving me that as a value 0.4128, etc. Now remember, that's the value for sine C. So if we want C, we're going to have to use the inverse sign. So we're going to press the shift key and then the sign of my answer. And that gives me the angle, 24.38. I'm going to round that off to 24.4 degrees. So 24.4 degrees. Question 6. You're given that sine 60 degrees minus sine 45 degrees equals half of open brackets root A minus root B, and we need to work out the values of the integers A and B. Okay, now this is not an equation where we're going to be passing things from one side to the other. It's more of a show that question. We need to start with one side of the equation, sine 60 minus sine 45, and make it look like the other side. Now I mentioned earlier that you need to know the exact values of certain sines, cosines and tangents. You need to know the sine, cosine and tangent of 0, 30, 45, 60 and 90. Now that's all these values in this table. So one strategy is just to memorize the table. If you've got a good memory, then perhaps that's the easiest and most straightforward way of doing it. You can derive all of these for yourself if you do happen to forget them. If you draw a equilateral triangle of side 2, 2, 2, 2, and then you divide that triangle in half like this. Okay, so that's half of that, so that's going to be of side 1. Then I've got a triangle which has a hypotenuse of 2 and one side 1, so using Pythagoras feeling I can work out the other side. The hypotenuse squared is equal to the sum of the squares of the other two sides. So this side is going to be the hypotenuse squared, subtract the other side squared, all square rooted. 2 squared subtract 1 squared is 4, subtract 1 is 3, so that one there is root 3. So using Pythagoras theorem I can work out that second side, shorter side of my triangle is root 3. And from at this point I can now work out all the sines and cosines. This angle here is 60, and if you think about it then this one up here is 30. So if I want to know the sine of 60, I'm going to use this angle in this corner. Sine of my angle is opposite over hypotenuse, in which case I've got the opposite, which is root 3 over the hypotenuse, which is 2. So that tells me that the sine of 60 degrees is root 3 over 2 from that little diagram. The sine of 45, Now I can derive the sine of 45 degrees from a different triangle. If I've got a triangle where there's the right angle and this is an isosceles triangle, that would make that angle there 45 and that one 45. So again, if I make this side 1 and 1, then using Pythagoras theorem, then this longer side is going to be the square root of 1 squared plus 1 squared. 1 squared plus 1 squared is 2. So then this side, this longer side here, is going to be root 2. So then if I want the sine of 45, here's my 45 degree angle. The opposite is going to be this one here, and the hypotenuse is this one. So that means the sine of 45 is equal to 1 over root 2. Okay, so there are your choices. Either you know how to derive them for yourself, or you remember all of them in this big long table. You don't really have another option. If you don't know them, you can't answer these sorts of questions. It's just not possible. Okay, so now I've worked out what the sine of 60 and the sine of 45 is. I can go on and do the maths. So what is sine? So I start off with the left-hand side. That's equal to the sine of 60 subtract the sine of 45, which I've just worked out is the root of 3 over 2 subtract 1 over root 2. So we're going to have a little bit of, we're going to have to put this as, now before we try and combine these two fractions, I'd want to put them over one fraction in a minute, but before we do, let's see if we can rationalize the denominator of the second fraction, because I think that will make it into a half, and that will make putting it over one fraction a little bit easier. So when you rationalize a denominator, you are timesing top and bottom by the denominator like that, aren't you? Okay, root 2 over root 2 is just 1, so multiplying anything through by 1 doesn't change its value, but it should change its form. So that's going to give me my root 3 over 2, which I already had, subtract. Now my denominator is going to become root 2 times root 2, which is just 2. So now that's good because it matches with my other one. And the numerator is going to become 1 times root 2, which is root 2. Okay, so now I can put them both over one fraction. So then that's a half, well, divided by 2, isn't it? It's root 3 minus root 2 all over 2. Okay, so we're almost in the right form now. All we've got to do now is rewrite that as a half of root 3 minus, running out of space, let me write over here. That's equal to a half of, open bracket, root 3 minus root 2. All I'm done is taken that, divide by 2 there, and written it at the front. Okay, but you'll see now it's in the same form as what I was requested to find. So I've got half of root 3 subtract root 2. So A is going to be 3 and B is going to be 2. Okay, now that's quite a hard question. You need to know about surds, you need to know about rationalizing denominators of surds, and more importantly, you need to know about the exact values of your trig identities. So you need to know the sine of 0, 30, 45, 60 and 90, and the cosines and tangents as well. Okay, so lots to learn if you don't know that yet. Question 7, work out the area of this quadrilateral. Okay, so we only know trigonometry in triangles, we don't know trigonometry in quadrilaterals. But if I take a ruler and I do this, now I don't have a quadrilateral anymore, now I have two triangles. So I should be able to work out the areas of both of them fairly straightforwardly. Now this one down here, so I'm going to say that the area of my quadrilateral is going to be the area of that red triangle, which is just a half times its base times its height, which in this case is going to be a half times 15 times 6, plus it's going to be the area of this green triangle added on. Now, with this one, I can use the second type of area of a triangle form that we know, which is the one involving the sine. So that is half BC sine A, we wrote down earlier as, didn't we? Okay, so then subbing that in, that's a half times B, which is one of my sides, 12, times C, which is the other one of my sides, 16, times the sine of 75. Okay, now it's just a matter of tapping all of that into the calculator and coming up with an answer. So half times 15 times 6 plus a half times 12 times 16 times the sine of 75. What's that equal to? Now, I make that 137.7, which I'm going to round off to 3 significant figures. So that would make it 138 units. Well, centimeters squared here, isn't it? Centimeters squared. Okay. Question 8. 2 soldiers A and B leave the same base. Soldier A travels 5 kilometers due north. Soldier B travels 6 kilometers due southeast. How far apart are the soldiers? Now, you'll notice from the layout of this question, they've given you this big white space and then some lines for your working down here, because what's missing from this diagram, what's missing from this question is a diagram. So what I would do with this sort of question first off is draw one. Okay, it's hard to just balance all those things in your head. So if this is the base here, then soldier A travels 5 kilometers due north. That's going to be, just going to use a ruler to keep it neat. So let's say he's gone 5 kilometers that way. Then that is going to be my soldier A. Now soldier B is not going southeast, isn't it? Which is a 45-degree angle down this way, south and east. So let's draw. He's going slightly further, so a slightly longer line going down here. It doesn't have to be accurate, but if it's vaguely correct, it should give us a bit more information if it isn't. So just making that triangle complete. Okay, so we've made our own diagram now, haven't we? So that's B down there. Okay. So now our diagram's complete. We can see we've got a non-right-angled triangle, a B base. It's not very handy. Okay, let's call it ABS for base. So I've got a triangle ABS where I know 2 of the sides, but that's it. Now, when I talked about trigonometry and non-right-angled triangles earlier, we said that we needed 3 pieces of information in order to use either the sine rule or the cosine rule, and so far we've only got 2. Or do we? Do we know the angle? We know that A was going due north and B was going southeast. Now southeast is halfway between east and south. Going east would be an angle of 90. Going south would be an angle of 180. So this angle is going to be halfway between those 2, isn't it? So halfway between 90 and 180, or 90 plus 100, so 90 plus 45. So this one is going to be an angle of 135. So now we do know 3 things about this triangle. We've got an angle and we've got 2 sides, and we want to find another thing. We want to find the other side. So when we've got 2 sides and an included angle, is that the sine rule or is that the cosine rule? Yep, you guessed correctly, it's the cosine rule. So we need to find side S, little s on my diagram. So can we formulate the the cosine rule for this triangle. So this is going to be side A, isn't it? It's opposite angle A. And 5 is going to be B, which is opposite angle B. So what we want to find is side S. So we're going to say that S squared is equal to A squared plus B squared minus, if you remember rightly, it's 2 lots of these two again, isn't it? So it's 2 lots of AB cos, and then it's going to be cos of the angle, which matches the same letter as what we started with. So it's going to be cos big S. Okay, so that's the cosine rule formulated for this triangle. So now it's just a matter of putting the numbers in. So A we know is 6, so that's 6 squared. B we know is 5, so that's 5 squared. Minus 2 lots of 6 times 5 times the cosine of 135. Now you can just bash it all in at this point, but I like to try and do as much maths as possible because I know my mental arithmetic is quite good, and tapping stuff into the calculator can sometimes lead to mistakes. So I'll try and do as much as possible. 6 times 5 is 30, doubled is 60. So what I type into the calculator is going to be a little bit easier. So 35 plus 25 is 50, 60, 61 minus 60 cos 135. So that's what I'm going to type into the calculator. And like I say, you could have just typed in that horribly long thing with all the brackets and it would have worked out fine. It's just the way I work. So let's just tap that in. 61 subtract 60 cos 135. What's that equal to then? Now that comes out on my calculator as 103 and 0.4. Now if you look at this diagram, 103.4 would not look right for the distance between A and B, seeing that A and B are 6 and 5. But don't forget, we still need to square root, don't we? So S then, the actual distance is going to be the square root of that. So it's going to be slightly more than 10, isn't it? Okay, so let's find the square root of that. Root answer equals, so that's 10.2 kilometers, I suppose. Yeah, 10.2 kilometers. Okay, we're done. Well, that's that. I hope you found the video useful. If you did, please hit the like button and consider subscribing to my channel. Also, check out the playlist on the right for more topic tests, or the one down below for past papers. See you again next time.